Equations for solving word problems. There are many types of equations besides the first-order equations with one variable. We will discuss a few examples where two other types of equations are used in word problems. Let's present a short overview of these two types of equations. Second-order equations with one variable. Second-order equations with one variable include equations that contain a single variable raised at the second power. In the next tutorials, we will see that the general form of these equations is shown in the following on screen. The left part of such equations is identical to the general form of quadratic expressions discussed in tutorial 6.4, where we explained how to factorize such expressions. In this paragraph, however, we will consider only a simplified form of quadratic equations, where the coefficient b is 0. Therefore, the problems discussed here will require the use of the reduced quadratic equation. We have the following shown on screen. Let's consider an example to clarify this point. Example 1. The area of a square is 4 cm squared more than that of a rectangle of dimensions 9 cm times 5 cm. What is the side length of the square? Solution 1. The unknown in this problem is the side length of the square, which we denote by x. Since the area of a rectangle is the product of its dimensions and that of a square is the second power of the side length, we obtain the equation shown in the following on screen. Hence, the side length of the square is shown in the following on screen. Square root of 49 can be 7 or minus 7. However, we consider only the positive root, as the side length cannot be negative. First-order equations with two variables. First-order equations with two variables have the general form. We have the following shown on screen. Where a and b are coefficients, c is a constant, while x and y are the two variables. For example, 3x minus 2y minus 6 is equal to 0 is a first-order equation with two variables as it contains two variables x and y where both are in the first power, hence the name first-order equation with two variables. To solve first-order equations with two variables means finding the values of the two variables. However, since there are a lot of possible combinations that can give a true result, we must have some additional information about the relationship between the two variables. For example, in our example, we may take x equals 4 and y equals 3 as possible solutions, as 3 4 minus 2 3 minus 6 is equal to 0. Yet, we may also take x equals 2 and y equals 0 as possible solutions, as 3 2 minus 2 0 minus 6 is equal to 0. Both pairs of solutions are true. However, in a word problem, usually, there are only a couple of values that fit the description. Therefore, as said earlier, we must have some extra information about the relationship between the two variables. This extra information usually forms another first-order equation and we solve it as a system. However, for now, it is sufficient to know that we express one of the variables in terms of the other variable and in this way, the original equation turns into a first-order equation with one variable, which we already know how to solve. For example, if we have given that in a class there are 30 students where the boys versus girls ratio is b, g equals 2 to 3, we can write the following as shown on screen. This is a first-order equation with two variables, as we can write it as the following as shown on screen. We have the following as shown on screen. As we said earlier, it is impossible to find the correct value of the two variables only through this equation, as there are many combinations that fit the description. Therefore, we use the help of the other clue, which says that the total number of students in the class is 30. Hence, we have the other equation shown in the following on screen. available, which helps to express one of the variables in terms of the other variable in the first equation. Therefore, since g equals 30 minus b, we can substitute this expression in the first equation to obtain the following as shown on screen. Now, we have a first-order equation with one variable, which can be easily solved. Thus, we have the following as shown on screen. In this first-order equation with one variable, we have a equals 5 and b equals minus 60. Therefore, the root b that gives the number of boys in the class is shown in the following on screen. Hence, the number of girls in the class is shown in the following on screen. Example 2. The perimeter of a rectangle is 12 cm more than that of an equilateral triangle with a 16 cm side length. Calculate the dimensions of the rectangle if its length is 2 cm more than its width. Solution 2. We can express the rectangle's length by x and its width by y. Since the perimeter of a rectangle is calculated by the formula p equals x plus y equals 2x plus 2y, and given that an equilateral triangle has 3 equal sides, we have the following as shown on screen. This is a first-order equation with two variables. Therefore, we need some additional information to solve it. This additional information is already available. We know that length is 2 cm more than width, i.e. x equals y plus 2. Therefore, we substitute x with its equivalent expression in the main equation to obtain the following as shown on screen. In this way, we obtained a first-order equation with one variable, where a equals 2 and b equals minus 28. Therefore, we obtain for the variable y, we have the following shown on screen. Hence, since x plus y equals 30, we have the following as shown on screen. This too is a first-order equation with one variable, where a equals 1 and b equals minus 16. Therefore, we obtain for the other variable x, we have the following as shown on screen. Hence, the length of the rectangle is 16 cm and the width is 14 cm. That is all for lesson 9.2.5. To continue this tutorial, please watch 9.2.6. Creating word problems from equations. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.